In this video we will calculate the roots, the extrema and the points of inflection of this function. First we start with the roots. We always calculate the roots by setting f of x equal to 0. That means we have to write 2/3 x cubed minus 1/3 times x equals 0. So how do we solve that for x? We cannot use the PQ formula because we have a cubic function, not a quadratic function. But we also have no constant value. A constant value would be something, if after this 1/3 x, there would be a +7 or something like this, anything that does not contain an x, that would be a constant value. But we don't have that. And if we don't have such a constant value, we can factor out the x. That means x times, and then in brackets, 2/3 x squared minus 1/3 equals 0. And now we have two factors. This is our multiplication, and here in front of this we have the x, and behind we have the brackets. So just as when we have the situation a times b equals 0, then we can say a is equal to 0 and b is also equal to 0. And that would mean here x is equal to 0 and 2/3 x squared minus 1/3 is equal to 0. So this is equal to 0 and this is also equal to 0. So here we already have our first solution, and this we solve for x. That means plus 1/3. Then we have 2/3 x squared equals 1/3, and then divided by 2/3. Then we have x squared equals 4, is that, and then the square root. We have then x is either 2 or minus 2. Now we put a number on the x. This is x1, this is x2, this is x3, and then like this we have the three roots of this function. So the next thing we can calculate are the extremas. We can either have minimum points or maximum points, but also when we calculate the extremas we can also get saddle points. Any stationary point. What is a stationary point? If we have this function, for example, and we imagine this function as a mountain, and there is a cyclist. He has to move up here, and at this point the cyclist neither goes downwards nor upwards. And the next point where that is so is here, and the next point is here. These three, this, and this, they are all stationary points, but they are all different stationary points. This is called a maximum. Maximum, because the height here is the biggest. This is called a minimum, because it is lowest here. And this one is a saddle point. So the saddle point, it goes downwards, and then saddle point, and it keeps going downwards. Or it can be also reverse, upwards, and then saddle point, and then keeps going upwards. So these are the three types of stationary points that we can have. And this is what we're doing here. And we calculate the stationary points by setting the derivative f prime of x equal to 0. Now first we make the derivative. 2/3 is a factor that stays. Then x cubed, the derivation of that is 3x squared, minus, and then here only the 1/3 remains. And we make it easier, 2x squared minus 1/3. And this we set equal to 0. 2x squared minus 1/3 is equal to 0, and we solve for x. Plus 1/3 divided by 2 and square root. Again, we have two values, because whenever you make the square root of any number, there's always a positive and a negative solution. So first you have plus square root of 4/3, and then you have minus square root of 4/3. These are the two places where we have the stationary points. Now we want to find out what kind of stationary points that is. As I said before, we have three different types of station points: maximum, saddle point, and minimum. And we find out by making the second derivative, f double prime of x. If we make the derivative of this function, we have here 4x, and this goes away. That means the second derivative is just 4x. And now we set in the x value for the x. That means we calculate f double prime of square root of 4/3. This is 4 times square root of 4/3. So I don't know what that is exactly, but it is surely positive, because a positive times a positive makes a positive, so we can surely say this is bigger than 0. And if it's bigger than 0, then we know this is a minimum. And we can do the same for the other value, this one, f double prime. And then, of course, we have a similar situation, 4 times minus square root of 4/3. That is plus times minus is minus, and anything minus is smaller than 0, and that means we have a maximum here. So we now know we have a maximum at square root of 4/3. Now we have a maximum at minus square root of 4/3. And we don't know yet the y value. And then we have a minimum at square root of 4/3, which is approximately 1.15. And also we don't know the y value. How do we find out the y value? Just by setting in the x values into the original function. The original function was this here. So we just set this in, the x values, then we have f of square root of 4/3 equals 2/3 times this cubed minus 1/3 times this. And you put that into the calculator, and this is approximately minus 2.05. We can put that here, minus 2.05. And you can do the same with the maximum. Then you just have to calculate f of minus square root of 4/3. And that would be, if you calculate that, plus 2.05. Which makes sense, because the maximum must be higher than the minimum, and the y value, which is the vertical value in the coordinate system, is higher in the case of the maximum. So that makes sense. So after having the roots of the function, the zeros, we also have the extremas now. The next thing would be points of inflection. What is a point of inflection? Now let me show that here. If you have any function that has curves, then it has two types of curves. First, this curve has a right-hand bend, and then it has a left-hand bend. And the point that separates the two bands from each other is the point of inflection. So before this point of inflection, we have a right-hand bend, and after we have a left-hand bend. That's the point of inflection. And we calculate the point of inflections just by setting the second derivative, f double prime of x, equal to 0. The second derivative we have already calculated. That is 4x. So we set 4x equal to 0. Then we just have to divide by 4. And then we have x equals 0. Now we know there is a point of inflection at 0. We just want to know what y value it has. Then we have to set in the 0 in the original function. And then we find out the y value is also 0. So f of 0 is also 0. That means we have a point of inflection at 0, 0. And now that we know all this, we know where the roots are, we know where the extremas are, and we know where the point of inflection is. Now we can make a rough picture of this graph. So we know the roots are at -2, at 0, and at 2. And we know that the extrema here, as I said before, square root of 4/3 is roughly 1.15. So that's about here, and then -205, say it's here about. And in the case of the maximum, it's just here. And the point of inflection is just at this root. So what we have is we have this is the right-hand band, and after the point of inflection comes the left-hand band, and it goes through all the 3 roots.